I want to talk about the state of data visualization on the web. Have you ever heard the expression, time is money or something like that? Well, that's not right. Time is more important than money. So what I'm going to try and do is I'm going to try and navigate the wilderness for you guys when it comes to data visualization, because there's a whole bunch of stuff out there, right? All the D3 guys and Python guys have their libraries, and all us web devs have like our stuff, but I think there's going to be a trend for more and more stuff towards the web when it comes to data visualization, statistics, machine learning, which is good for us because, let's be honest, we're getting bored of web development. It's just like moving divs around on the page and displaying data. So we have choices. We have choices when it comes to everything. D3, Kibana, Vega, WebGL, Ubers, 3GS, Babylon.js. How do we pick what to do when we want to have a data visualization solution? So we just like come to these roads and we're like, do we go right or do we go left? Or do we go around the roundabout and down that road there? So the future of data visualization, according to my humble opinion, or maybe not so humble opinion, is WebGL and JavaScript. There's some really cool stuff that's going on right now. Does anyone like Mandelbrot sets where you watch these zoom and you zoom into the Mandelbrot set? Well, you can do it in 3D with WebGL, and this is some funky stuff, man. I'm writing a 3D strategy game with the Babylon.js. Now, obviously, as programmers, we can code any logic we want, so you could actually come up with a data visualization solution that nobody's done before just by using your programming logic and some of these like native 3D objects that the Microsoft made this framework called Babylon.js, which is what I'm using here, and that allows it's a very high performance framework, allowing you to hide the gory details of WebGL from you. So what Uber have done, and I actually talked to the guy, the main committer for this, what Uber have done is they've actually created a small wrapper around WebGL, which doesn't hide you from the low-level WebGL stuff, but it sort of makes it a little more friendly. And they build this thing called DickGL on top of their Lumina thing. And what it is it basically allows you to visualize big data. It can plot millions of points on the screen at once using like even just my rubbish Mac here, which is 2015. So by big data, it's really hard to visualize sometimes what you've got. But with these kind of things, you can actually start to visualize them. So they have all their stuff kind of written for React, but I was talking to the guy and he says they're actually trying to extract it out of React so that anybody can use it on any framework. These are like city things and all that stuff, and like, I'll basically show you what it is in a minute. Visual exploratory of large data sets. And this is Google Facets, which is another thing. So they kind of pitch it as, so machine learning, right, basically takes data and categorizes it, to certain, like you want to categorize something as a cat or a dog, or categorize whether this drawing matches a chair or something. So, or even just like data you want to visualize, but in a way that's kind of without having to go through a spreadsheet. This facets thing really helps you. I'll give you a live demo. This is basically what it does. So, let me just show you a demo. So this is 10,000 data points. It's a 2D drawing, but it's over on a WebGL canvas. And if you actually can see how, this is real time, by the way, so that I can actually navigate this. You can click on any data point and you can see the data here. And this is not possible with D3 or SVGs. And what you can do is you can actually categorize, you can actually facetize these things into rows and columns. So for example, if we take, if we go to faceting, we can do row-based faceting on, say, age, and it'll put them into bins, which you can set. So you see that animation there? That's all those things moving individually. And this is a rubbish Mac I've got. And so this is like, you can see here, so these are like, you can colorize by, I think this is by occupations. So you can colorize by other things. You can colorize by something like marital status. So you can see like all the red stuff here, young people basically were never married. And then as you go up, more people are married. And then you got this like divorced area around. A lot of people will get divorced around 39, 54, right? I don't know why I picked that. Keep picking this that thing. It's kind of sad to look at. But anyway, you can also then call facetize it by another way in the vertical one. So you can do by race, if you want to see how the marriages are per race. So there we are. So you can see here that, to be honest, it looks like the proportions for race are kind of like similar. But anyway, this is basically, you can put any kind of data in here if you want. Like this one here is another one. This is machine learning data set. So you have a bunch of drawings that to recognize like a face or something. I think it's loading. All right, there's supposed to be a lot of like faces in here. Oh well, skip that. This is the best bit here. This is WebGL. So this is the best. Like I've never seen anything like this before in the browser. This is crazy. Like this is like real time 3D points in the cloud. I don't know if my internet's working fast here. Fine. I think it's just loading a lot of data. All right, here we are. So this is crazy, right? These are all like individual points that you can plot. And you can imagine running this on like a decent Mac, like with a GPU. There's another cool one where you got like all these like street accidents in the UK. So you can basically see what's going wrong in London with all these accidents. And then you can like change the radius of the points to get even more resolution. So this is like, now we're drawing a lot of points right now. And go check it out. Oh, there's our faces. So like this is a machine learning data set, and so each point has like if it's recognized or not. So you can actually color by things like, is it recognized? And then the computer will say, this is basically, you can categorize by these facets, vertical, horizontal, and then you can go and see what the computer, so this is basically, it's not recognized as a face, right? And this is, like, so this is like, computer looks at that and thinks, nah, that's not a face, neither is that. Although some of them are like, I don't know why it doesn't think that's not a face. And like, there's like, also you can like, these are like strokes, I think. It's like by a number of strokes. So like, somehow it thinks that, you think that maybe the more strokes would be more accurate, but sometimes with machine learning, the more strokes there are, the worse it gets with trying to categorize it. So the more simple, like, to a certain point, right? I mean, it's like a bare minimum. There's like a sweet spot. So you can look at this data and you can very quickly see like what's happening, and like by time of day and stuff like that. I think, I don't know what that is. Word. Okay, so I'll just go on the rest of the slides. So we have deep learning capabilities in the browser. This is one of Google's latest projects. So all people like me that have basically programmed for 9 years, I can't be bothered learning Python, and I just don't want to learn another language. Now we don't need to learn another language. We can use our JavaScript skills to use machine learning. And they actually have things running in the browser, like playing piano, real time, based on what the machine has learned when it comes to looking at other composers, and it's actually running in the browser. What it does is it shifts all the complicated calculations from JavaScript over to the GPU, and then it gets the results back from the GPU into your normal JavaScript programming. 5,000 stars. I'm actually just looking at this. I'm going to have to do a bit of research on it. I'll make some YouTube videos once I figure out what's going on, because I didn't like one of the things the guy wrote in there. He wrote something like, you need Visual Studio or Microsoft Code to run this thing. I was like, whoa, I might go in there and start putting through some issues, but you know, it's exciting. Another thing, Microsoft have their own version of Google Facets. So it's called Sandance. It's been around for actually about 4 years. There's a similar kind of stuff that's binning, this faceting or binning. And D3, we all know what D3 is. Anyone use D3? So D3 is like SVG. We all know what it is, right? It's like a tool set. You've got NVD3, which is like the chart, the sort of easy chart wrapper around D3, if you can use that. And it's like a MacBook version of this tool set. You've got Vega, which is another sort of wrapper around D3. So instead of using procedural code, you've got these sort of declarative JSON files, which specify how things should look. I've not used it, but I've played around with it. You've got Kibana. Kibana is like a thing that looks at a bunch of JSON, and then people like to build dashboards around it. And that's it. So lots of competition for these guys, quick pace of development, lots of opportunities for deep learning, and so and so. And that's it. Thanks for listening.